Let us move on to advanced level questions. So I'll just explain you this question. There is a two fixed plates here and there is a movable plate here. The viscosity N2 is given as 4 times eta 1. Okay. And the separation between these two plates is h. The question asked is, what should be this h1 in terms of h, so that we can move this with constant velocity with the minimum force possible. Okay, so for different placement of this plate, this force, there will be different values. So for where should we place this plate from the top one, so that the applied force to move it is less. So if this force is F, let us just write the expression. So what is the viscous force? Tell me. F equal to, so here for this liquid we can write eta 1 A. Suppose it is moving with speed V by h1. From here it is h1, so V by h1. Now here there will be viscous force. Here also there will be a viscous force because of this liquid, plus eta 2A V by same speed. What is this length? H minus h1. H minus h1. Now if this has to be minimum while wearing h1, what can we say? For minimum F with variation in h1, we can say df by dh1 equal to 0. Okay. Here what will we get? Eta 1. So if we just differentiate this, I'll get this as minus eta 1 AV by h1 square. This will become plus eta 2 is what? 4 times eta 1. Must be equal to 0. I can cancel out this eta 1 here, and I'll get 4h1 square equal to h minus h1 whole square. Or if I just take square root, 2h1 equal to h minus h1. Or directly from this we can say h1 equal to h by 3. So for h by 3 distance from this, the force applied will be minimum. Okay. Let us move on to the next advanced question. This question is taken from Pathfinder. I'll explain you the question. There is a square plate here, and initially this plate was here. Okay, this is a table, and on this there is oil. Now what is done is, this square plate is pulled here with a constant force. He's asking, what is the time taken for this square plate to come, till half its length till here. Okay, so this is F, and here there is some viscous force acting. Okay, so what can we write? Tell me here. F minus F viscous equal to mass into acceleration. In the question he has mentioned that it is a inertialess metal sheet. Inertialess metal sheet is almost the mass, we can take it as negligible. So we can take this 1, 2, 3. So we get this as F minus, what is FV? FV is nothing but eta into area. See, what is happening is, as the plate is moving this side, the area of plate in contact with this lubricant which is there is changing. So what we'll write is, so this viscous force is going on changing. So what we'll write is, at a certain time, let us write what is the viscous force. So suppose the distance from here to here is x. So what is this distance? This will be L minus x. So I can write F minus eta into what is the area L minus X into L. That is the area that is in contact with the liquid. Okay. Eta A, suppose the speed at this instant is V. So this will be V, and this thickness of this is he has given us H here. I'll just write it as H equal to 0. Okay. The question that he's asking is what is the time that it takes for the plate to come out of this table by half its length. That means he's asking the relation between time and x. Here we have x and v. We can write v equal to dx by dt, right? So I can just write this as f equal to eta L minus x into L by h. This v I can write it as dx by dt. Okay. And now we can just put in the limits. So what all will be there to me? F h by eta L into dt equal to L into L minus x into dx. This L we have bought it here. We don't need this here. Now I can integrate this. How can I integrate this? When x is 0, the time is 0. Okay. When t is some t, we need to find the time t. At this becomes L by. Now we can just integrate this. What will we get? Fh by eta L into t equal to. So this will come out to be L into x minus x square by 2. Just put the limits 0 to L by 2. If I just calculate what this is, what will we get? L square by 2 minus L square by 8. So this part comes out to be 3L square by 8. Okay. So what will be time? Tell me from here. This time t equal to 3 eta L cube divided by 8F into H. If you put in the values and calculate, this comes out to be 5 seconds. Okay.